After doing several prints, I decided I might as well make a grid and see exactly where my sintering is working and where it isn't working and where I can make modifications. Check this out.
Here's something I've been working on for a while, or just thinking about. So I've always wanted to have live text that I could basically 3D model in Catia, and their text utility is just awful. So I wrote a reaction that does this. It's just simple. It's just a bunch of conditionals inside of a for loop that parses out the string that you want to have from a parameter, and then that just dumps into an output curve, and then that output curve is just joined, it's just assembled. There's some rules for like the orientation of the text and everything, but now all you can do is just take a simple parameter like this, and right now it just does numbers, but you can put in any number you want, and then it will put in that number on the thing, and then this is extrudable. You can make it into solid. So it's lightweight. I mean, it's only something like 7 objects, and then I just made sketches for each of the things, because every time I tried to use like an actual font, there were just so many curves and lines and constraints that it made the whole item so heavy. And then it's just saved as a UDF. So I have a UDF that has a bunch of parameters underneath it, and then that's just dumped into wherever I want. And then I automated it so it could go into this other file I have here. So it's just a simple little instantiation script that puts the text on a pad, and then that same text is then pocketed underneath. I'm going to use this to calibrate some 3D prints I'm doing with the Sintratec SLS printer, and the bed is 11 by 11, so this is 10 1 centimeter by 10 1 centimeter little boxes with numbers, and then with the numbers I'll be able to tell which areas are not sintering correctly, because I'm getting some sintering issues around the perimeter. I assume that the corners are going to be bad, because that's pretty typical, you know, like with this, is that the corners are kind of a no-go zone until you really get your machine fine-tuned. But at least with this, I'll be able to know for sure, oh yeah, number 1 and number 10 and number 00 didn't do it, or number 86 isn't sintering, and then I'll be able to fine-tune it a little bit better than what I'm doing now, which is just printing and hoping that it's going to work. I'll make all this public, so like this model here, I'm going to use my export script and bring it into Sintratec, and then save a STEC file of this setup so that other people can just use this.
So here's the setup for my calibration grid. You know, with all of the Sintratec kit preparation, it dumps a bunch of powder on there, so it takes about 20 layers, or I think I counted 26 layers. So right now it's doing that layer after layer after layer before it starts sintering. The grid takes up an 11 centimeter by 11 centimeter footprint, and they're actually 9 millimeters squares. I said 10 millimeters, but that's wrong. And something like a 3 millimeter gap in between each of them. Anyway, each of them have a number, and once the preparation is done, it's going to start sintering all of the numbered squares, in the hopes that I'll be able to figure out exactly where my sintering is not working. Like I'm not having a lot of major issues, but I just want to know the full extent of what I can do. And the other good thing about doing this grid is, as you can see, it's starting to populate the grid right now, is it allows you to adjust the temperatures in real time and see where you're getting curling. So in this first round right here, I started it with 172.2 degrees with a laser speed of 550. Numbers 8 and 9 and 19 had curling issues, and what it would do is it would cause a plowing issue, which I've been calling plowing. Basically, it curls so tall that the applicator fin will will catch, and it will drag that element and plow anything that's to the left of it off into the overflow bin. If you're lucky, it'll go into the overflow bin. I've also had it catch and then stick and then go back into the right side of the bin, and then it's effectively totally shot. So you can see right there, the plow just happened on the bottom of the front of the bed, and it still keeps sintering if you keep going. So I adjusted the calibration. Now it's at 172.7 degrees with a 550 laser speed. I still had curling issues, and as I still had curling issues on the front right side, which is basically elements 9, 8, 18, and 19. Also had curling around 92 through 98, which is the full left side. So after a bit longer, I think right about now, because I still had issues, then I adjusted it even more. So I moved it up to 173.2 degrees, and still continued with a 550 laser speed because I still had curling on the corners, and that helped. You can see right there, there was no plowing on that last row, and it allowed for the layers to catch up. So every time it puts more powder on, it's filling that channel on the front side. However, eventually that still didn't really work. I still had a bit of curling on the right side, and then I lowered the laser speed to 525, which helped dramatically. There's more plowing right there. Basically, no matter what temperature I tried to do, that bottom corner, the front corner on the right side, almost never functioned properly. There was just nothing I could do to get the curling to stop on the front right corner, and I eventually just aborted the whole project because it didn't matter how much I was increasing the temperatures. It didn't do anything. So yeah, I aborted that project and just examined the squares that came out of it. I had some delaminating on the left side as well, and so like some of the 90s that are on the left side, especially near the front, like the layers sintered properly and didn't curl, but they just didn't adhere together well. There was like a tiny little layer of powder that was in there, and it was just going against trying to work with an object in that corner was just a waste of time. So on the second print, I continued with the 173.3 or 173.2, which should start any minute now on the time lapse. And eventually I did bump it up to 173.7. And that's a really high temp. I wouldn't even really recommend going to 173.7 because what happens is you get great sintering along the perimeter and it seems like you're maximizing your footprint. And I actually did print a model using this, using the information that I got out of this, this grid. The problem was that the center, which is numbers 44, 45, 54, and 55, would just fuse together. All right, so that was okay. The one that just ended was 173.2, and I had curling at the corners. So I think this next one here is, this one here is where I upped it to 173.7. And the hope here was to eliminate any of that curling on the corners, really any of the corners. Like I say, at this time, I'm basically just trying to see what the extents of what this machine can do. Maybe I can get the corners to work, but it's just, after doing all these tests, I did something like a dozen tests. That's what all these time lapses are. And there are other ones that aren't even filmed. I did, like my card filled up. My overall advice is just to avoid putting the corners in all together. So 00, 09, 99, and and 90. Those squares I'm going to remove from my calibration grid just because no one should really even try to get those ones to sinter. And running the calibration grid is just going to be this cycle of trying to get a few squares to print without it plowing them all the way through the other side. All right, so at 173.7, I did have some curling on 9 and 4, but it got a lot less, and I think that's where we're at here with the time lapse. Another thing that isn't in this particular video, but it's kind of, you can kind of see it, is there on numbers 8 and 9, I had a bit of a shadow. I talked about it in the other video, and the laser couldn't actually get to the powder because something was blocking it, either in my glass that's on the underside of the ceiling, or maybe something to do with my insulation. My insulation isn't properly aligned with the metal grid. So if you look down at the bottom right, like the front right, you'll see that numbers 8 and 9 don't actually center into a square. They kind of look like a trapezoid because there's just a laser can't get to it. All right, so in that one was at 173.7. So it did catch and it plowed all the way across the middle, but I started to increase the temperatures just by 1/10 of a degree, and just to see what I could get out of this thing, even though it totally catastrophically failed. I mean, through the middle of the grid, I had several squares that just didn't work. I just kept going with it because as long as it doesn't curl back into the right bin, the right side bin, then you can keep going. And you're probably wondering, why isn't it applying powder to the whole thing? Well, even the slightest depression in the bed, on the left side bed, will fill up, and then the powder won't flow all the way to the outside, all the way to the overflow bin, because it still has to keep refilling it. Eventually it will refill it, as you can see in the video. It's gradually working in there because I bumped it up to 173.9 at this point, and all that was curling now were the corner pieces. And even those corner pieces really weren't curling that much. Was kind of surprised. 173.9 is extremely hot, and what I learned later on is the center squares just fuse together, and you can't break them apart. You can break them apart, it just takes a lot of work. Well, anyway, this thing just kept going until I was just testing to see how far I could go with it. Obviously, a lot of the front squares aren't usable, and the left squares aren't really that usable for examination purposes because they just keep getting plowed out of the way. But that's only because the corner pieces kept plowing them out of the thing. That's what's the beautiful thing about this particular grid, is you can keep testing even though it's a failed project once it starts plowing. But because it only plows that row out of the way, you're not ruining all of the other squares. So like I highly recommend using it just to kind of see what your machine can actually do. And it doesn't use a lot of powder. This thing's only, I think, 3 millimeters thick or 4 millimeters thick, like each of the squares. So a tiny bit of powder, put it in the machine, test it out and see what you can get out of it. And then just to keep increasing your temperatures to find where you can get your optimized volume. And you figure out where you can get like a good square, something around an 11 centimeter square, and then when you pull it out later on, wish I had video of this, you examine the center squares and make sure that none of them are fused together, because if they're fused together, you went too hot. So 174 is going to be too hot. I went 174. You can work with 174, and then you can get a really big square, like a really big footprint, but it's a lot of work, especially if you got interconnected parts, or if you have any parts that have little channels or little tubes. It's over with. The powder in there is fused. If you have like a simple model that doesn't have a lot of internal geometry, then maybe you can go that high in the center, but your parts next to each other will fuse together, and there'll be this buildup, this plaque along the outside. So that's kind of things you need to look at when you take it apart. And then the last thing is just make sure to look at the elements along the perimeter, like they're all labeled so you can tell which ones are on the perimeter, and make sure that they're not delaminating as well, because that could also influence on what your build volume can actually do. Overall, this is like a good indication of like the extents of what my bed can handle. Over here, I got a little bit of over on the right, I got a little bit of adjustment there I gotta do to get my sintering all the way over. And then the far end sintered great, which is kind of counterintuitive because the way that the infrared lights are set up, that, you know, I would think actually the sintering would be worse here, but instead it's great. And then on the front here, this front row really doesn't sinter well at all. On the right side, it actually sintered great, except for where I have that shadow. So I might expand the limits of my bed. Yeah, this is like a good sign. Basically, kind of shows me that I have good sintering everywhere in the bed, except for on this corner here, and then on these two squares here. If I fix my shadow issue here, or wherever it's blocking my laser light, and I avoid like these two squares and this corner here, I should theoretically have a full range of sintering action for this thing. So after examining all of the pieces that came out of the bed, I decided to go back to my original model, my parametric model, and identify all the areas that had problems. So red were areas that just didn't sinter at any temperature, and just nothing I could do. And then orange were areas that had either slight curling or just areas I don't want to deal with. Also, I had some delamination issues along these 90s here that were on the side. The bed actually is arranged this way. It's kind of backwards. I should have modeled it differently in Catia. But when it goes into Sintratec, this is the orientation that these come into. And I export these STLs, which go into Maya, and then I use my exporter script to make sure that they're oriented correctly into Sintratec Central, and then I reset all the XY coordinates and then save it as an STEC. So I'll just post the STEC file that I made of this here. Now, what I won't post is all of the colors and all the changes, because your bed may be different than mine. You kind of have to use this information, so all of the pieces that came out, check them all, and then identify which areas were bad. And then I made this boundary volume, like it's easier to see from the bottom, but this is basically where it's safe. And anywhere that it was orange, I went through the middle, and then anywhere that was red, I just completely avoided. And then in Sintratec Central, and also in Maya, I can situate all of my parts inside of this purple volume and know that I'm going to have good sintering at the temperature that I tested this at, which for one of my largest builds, I did use a high temp so I could get a bigger footprint, but I did have some issues on 55, 54, 44, and 45 because it just got so hot in the center. But I might do a couple more tests at slightly cooler temperature and then just see which of these squares become red and which of them become orange, and then that smaller volume, I'll have to make sure I work inside there. I know that Sintratec recommends that you stay within an 11 centimeter square, and by using this grid you can identify exactly where you can push the limit. Like this doesn't look like a square. In fact, this corner here is kind of useless and that corner is useless, but surprisingly my the back side, the side that's along the back of the oven, sintered really well. I don't know if that's just because it has that electrical connector or electrical heater in the back, and that just transmits through the wall, and that allowed for the geometry in the back to sinter really well. I don't know. But by using this grid, now I know what it can do. And one of my largest prints, both in footprint and in height, it was over 800 layers long, and had something like 100 parts. It had 125 parts. And the only reason why I killed it early was I had a little bit of
powder that clung to the tray and it was causing a line across them. So I think I'm confident I could have gotten the full 1100 layers if it just didn't have that line that was on there.
So here's basically the exported solid that I made from my Catia model, and I brought it into Maya, which I find to be easier to nest parts. And as you can see, I can really fit a lot of parts in. All you really need is a millimeter of space, even less really, and I just fit as many of these pieces as I can. And because I'm well within the boundaries of my solid that I created, I know I'm going to have good centering, and then I can bring it into Sintratec Central and just use my exporter to bring all these things in at the right space, so the right orientation and XYZ coordinates. And yeah, this printed pretty well. Like I said, it would have completely finished if it hadn't just got a little speck of powder on the fin. But that's the way that I've been able to secure large prints without having curling and other major issues.
Anyway, I'll post this model, the S-Tech version of this model, and you know, you feel free to use it however you want to use it. I think it's a really useful calibration tool for identifying how you can optimize your footprint based on certain temperatures and also laser speeds. So good luck.